So you know how AI is getting crazy good at understanding what we want? Well, what happens when we ask it to actually do something in the real world? We're moving past just searching for information, we're asking AI to take real actions. And that raises a huge question. How do we build AI tools that can act for us, but do it safely and reliably? All right, let's really get into it.
So first things first, we've got to talk about a really key difference. For ages, we've basically been using what you could call read tools. Think Google search. They go out, find information, and show it to you. But now, we're stepping into the era of write tools. These tools don't just find things, they do things. They can change data, send messages, and actually modify the world. And right away, the stakes are just massively higher.
And that right there is the whole point of this explainer, the power and the peril that comes with it. When an AI can actually write to a database, fire off an email, or delete a file, it has real, tangible power. And you know what comes with that power, right? A whole new level of caution we have to bake into these systems from the ground up.
And let's get specific about what those stakes are. We're talking about tools that can change data, maybe forever. Think about it. They can send messages that look like they came straight from you, representing you to your boss, your team, your customers. Every single action has a real-world consequence, which is why we can't just let them run loose. No way. They absolutely need strict validation, and this is the big one, human oversight.
So how do we get that human oversight? Well, the number one way, the most important idea here, is something called the human approval pattern. It's a really simple concept, but it's incredibly powerful. Before the AI does anything big, a human, yep, that's you, gets the final word. And this slide, it lays out the flow perfectly. Step 1. The AI model comes up with an idea, an action it wants to take, like send an email. Step 2. The server translates that technical request into a simple, plain English summary. Step 3. That summary pops up for you in some kind of approval screen. Step 4 is your moment. You can approve it, reject it, or maybe even tweak it a bit. And only then, step 5, if you give it the thumbs up, does the server actually go and do the thing.
Now, what's so cool here is the breakdown of what makes a good approval summary. It's not just about what the action is. It needs a clear, one-sentence summary, a risk level, is this a no big deal or a be careful kind of action, and this is so important, the consequences. Telling a user an email cannot be unsent. That is absolutely critical information for making a smart decision.
But look, a pretty UI for approval isn't enough on its own. Behind the scenes, you need some serious technical safeguards to catch errors or even malicious stuff before an action ever gets to you. This is where we build a truly safe system, using what we call the 4 layers of safety.
Just remember this number, 4. Every single action the AI wants to take has to pass through 4 different layers of checks. Think of it like a series of security checkpoints at an airport, each one getting a little more strict.
Layer 1 is the most basic one, schema validation. This is basically the bouncer at the club door. It's just checking the fundamentals. Does the request even look right? Is that email address formatted like an actual email address? Is a required field just completely missing? It catches all those simple structural mistakes right at the start.
Next up, Layer 2, business logic. This is where your app's specific, custom rules come into play. Things a basic check wouldn't know about, like, hey, are we only allowed to email people at ourcompany.com? Or maybe, have you already sent too many messages today and hit your rate limit? This layer enforces all those unique policies.
Layer 3 is all about permissions. Super simple, but super important. Does this specific user actually have the green light to do this thing, right? You probably don't want an intern accidentally deleting the main customer database. This is the layer that prevents that from ever happening.
And last but not least, Layer 4, the approval gate. This is what connects all our techie safeguards back to the human. So, even if a request is perfectly formed, follows all the rules, and the user has permission, if that action is flagged as risky, this gate slams shut and says, whoa, hold on, go ask a person first. It's the final checkpoint.
Okay, 2 more quick but crucial tech concepts. First up, idempotency. It sounds complicated, I know, but the idea is really simple. Ever nervously double-clicked a Buy Now button online and had that mini heart attack wondering if you just got charged twice? Well, idempotency is the magic that prevents that. It guarantees that doing something twice or 3 times has the exact same result as doing it just once. It's an absolute must-have for building systems you can trust.
And second, we have rollback mechanisms. Think of this as the ultimate undo button for your AI. Because let's be real, sometimes, despite all our best efforts, mistakes happen.
A rollback mechanism, like maybe a soft delete that just hides data instead of erasing it forever, gives you a path to reverse the damage and fix things. It's your safety net.
All right, so that's the theory, right? Approvals, safety layers, sounds good. But what does this actually look like in the real world? Let's break it down with the 4 most common right patterns you're going to see out there.
First up, the big one, create or add. We're talking about making something brand new, like creating a calendar invite, adding a task to your to-do list, or opening a new support ticket in the system. Super common.
And check out this example summary. It is perfectly clear, no jargon. It tells you exactly what's being created, where it's going, and what properties it'll have. You can see in a split second if it's right or wrong.
Pattern number 2 is all about update or modify. So you're not creating something new, you're changing something that already exists. Think changing a project's deadline or updating a ticket's status from in progress to done. And once again, look at how clear that summary is. You're not just doing something to ticket 1234. You are very specifically changing its status to resolved and adding a comment. There is zero room for misinterpretation.
Pattern 3 is send or notify. This covers any time the AI communicates on your behalf, sending an email, a Slack message, you name it. And these are tricky because they carry social risk, right? Sending the wrong message to the wrong person can be awkward. So clarity is everything.
This summary nails it. It gives you the what, the actual message, the where, the @engineering channel, and the who, it's mentioning @Alice. A quick glance here can save you from a seriously embarrassing mistake.
And that brings us to the final, and let's be honest, the scariest pattern, delete or remove. This is the big red button. It's often permanent, so it needs the most care and attention by far.
And just look at the difference in this summary. It's not just information anymore. It is a warning. You've got the warning emoji, the word delete is in all caps, and that little phrase in parentheses, cannot be undone, is designed to make you stop, take a breath, and be absolutely sure before you click approve.
Okay, wow, we have gone through a lot. So let's boil all of this down into a simple, practical checklist you can actually use when you're building these kinds of tools.
Okay, here's the game plan. 1, implement that multi-layer validation. 2, always generate clear human-readable summaries. 3, for anything even remotely risky, you have to require human approval. 4, make sure your actions are idempotent so network glitches don't cause chaos. 5, keep an audit trail of everything. And 6, wherever possible, give people an undo button. That's it. That's the blueprint for building safe AI tools. So as we finish up here, I just want to leave you with this one question to think about. The AI we're all building is getting ridiculously powerful. It's becoming an extension of our own ability to act in the world. So the real question you have to ask yourself is this. Your AI is powerful, yes, but are your safeguards powerful enough to match?